Hello, my dear students. Welcome to the session. Continuation of important observations from power electronics concepts. In this session, I am going to starting module 3 choppers, that is DC to DC converter. With respect to choppers, I would like to discuss about buck regulator, that is step down chopper, boost regulator, that is step up chopper, buck boost regulator, that is up down chopper. Practice questions on buck regulator, boost regulator, and buck boost regulator, types of choppers based on quadrant operation, and what is the Fourier analysis of type A chopper, and steady state analysis of type A chopper, voltage control techniques in choppers, types of choppers based on commutation, mainly voltage commutated chopper and current commutated chopper is important, multi-phase choppers and SMPS. With respect to DC to DC converters, all these topics are important mainly for gate exam. Friends, all of you concentrate. First, we have to start with some introduction. Friends, we know that in DC to DC converters, fixed DC is converted into variable DC. In DC to DC converter, before developing the direct conversion from DC to DC, we are used AC link chopper. AC link chopper means it is a combination of inverter and rectifier. In AC link chopper, first DC is converted into AC, then AC is converted into DC. But what is the drawback of this AC link chopper? Because of two-stage conversion, the conversion losses are high. Because of two converters, cost is high, size is also high. These are the drawbacks. To overcome these drawbacks, to convert DC to DC in a single stage conversion, a DC choppers are developed. A DC choppers are nothing but a DC to DC converters. There is no DC to AC, AC to DC. Directly you can convert DC to DC. But in AC link chopper, DC is converted into AC, again AC is converted into DC. But there is a drawbacks. To overcome the drawbacks, directly we are using DC choppers. These DC to DC converters are again two types, that is choppers and SMPS ones. If the DC to DC converters are used for high power applications, those are called chopper. If the same DC to DC converters are used for low power applications, those are called SMPS. But you have to concentrate. This is what exactly a chopper. It is a static power electronic circuit which converts fixed DC to variable DC in a single stage conversion. It is basically high speed on off semiconductor switch. It may be thought of a DC equivalent of AC transformer. That is, DC to DC converters are a DC equivalent of AC transformers. Why the name is DC equivalent of AC transformers? That is, by using the choppers, we can step up the voltage, step down the voltage. Like in transformers, in transformers we can step up or step down the AC, but in choppers we can step up or step down the DC. That's the reason why a chopper or DC to DC converters are a DC equivalent of AC transformers. What are the different types of chopper switch? Based on the output voltage level, there is a buck regulator, it is also called step down chopper. The boost regulator, that is also called step up chopper. Buck boost regulator, it is also called up down chopper, and choke regulator. Mainly in gate exam, according to gate syllabus, these three circuits are very important. Very important, these three circuits only. Most of the time, minimum expected weightage from the choppers is we can expect 2 marks to 3 marks. Only from the choppers 2 to 3 marks. Even from the inverters also, in the next module that I will give, that also 2 to 3 marks we can expect. If you don't have the time, minimum try to prepare only choppers and inverters. Minimum 4 to 5 marks we can expect from these two topics. But in choppers, these three circuits are very important. But extra I am giving types of choppers based on commutation, because in gate 2024, based on that the questions are framed. That's the reason why I am going to giving the types of chopper based on commutation also. That observations also you have to concentrate. These are the types of choppers based on quadrant operation. Type A, type B, type C, type D, type E. This is also called class A, class B, class C, class D and class E choppers. But these are not that much of important for gate point of view. But ESC and PSU's point of view, this is important. For gate point of view, just 1 or 2 point mainly you have to concentrate. Only formulas you have to concentrate. Then types of choppers based on the commutation. Voltage commutated chopper and current commutated chopper. These two are very important for gate point of view. Remaining choppers are important for ESC and PSU's point of view. Multi-phase choppers, only one time it is framed in gate exam with respect to multi-phase choppers. Then these are some introduction points that you have to go through this. No need of concentrate those points. Start with the first circuit. Operation and analysis of buck regulators. Whatever the formulas I am giving, those formulas mainly have to concentrate. 99.99% students from the choppers, direct formula based questions only we can expect. In this circuit, just by seeing the circuit, how to identify the buck regulator or step down chopper. Buck regulator is also called step down chopper, or it is also called V to I converter. Very important. Buck regulator is also called step down chopper, or it is also called V to I converter. By seeing the circuit, how to identify the buck regulator. If the inductor is at load side, inductor is at load side, or a diode across the load, then it is a step down chopper or buck regulator. If inductor is at source side, we can easily remember like this. If inductor is at source side, then it is a boost regulator. If the inductor is at middle of the circuit like this, then it is a buck boost regulator. Like that you have to identify. For buck regulators, you have to take the two references. Take one reference is inductor is at load side or a diode is shunted across the load. The two references. For boost regulator, only one reference. If inductor is at source side, that is a boost regulator. If inductor is at the middle, then it is nothing but a buck boost regulator. These observations are important to identify the given circuit is a buck regulator or boost regulator or buck boost regulator. That you have to concentrate. But the analysis of buck regulators. Every chopper or regulator is analyzed in two conditions. Chopper on, chopper off. Chopper on, what is the KVL and KCL? Chopper is off, what is the KVL and KCL? In competitive exams, directly from the KVL and KCLs also questions are asking. Not only final formulas, mainly final formulas are important. Along with some equations also it is asking. This is the voltage across the inductor during chopper is on. And this is the current through the capacitor during chopper is on. Just I applied the KVL only. That you have to concentrate. Next, chopper is off. If the chopper is off state, what is the voltage across the inductors? If the chopper is off state, voltage across the inductor equal to minus V0. What is the current through the capacitor? IL minus I0. These observations are important. Next, these are the waveforms, but no need to practice the waveforms. Directly you have to concentrate on the analysis. The first one is average output voltage. I derived this average output voltage, but no need to concentrate on the derivation. Finally, you have to concentrate the average output voltage V0 equal to dVs. In the case of buck regulator or step down chopper, what is the average output voltage? The average output voltage V0 equal to dVs. That you have to concentrate. What is the D here? D is the duty cycle. D is the duty cycle. What is the range of duty cycle? 0 less than D less than 1. How to define the duty cycle? On time by total time period. This also you can write on time into frequency square. And that is from this, what is the T on equal to dt? What is off time equal to 1 minus d into t? These formulas mainly how to concentrate. This I given. Please go through this one. This is on time. T on is nothing but on time. It is also called pulse width or conduction time. T off is nothing but a off time. It is also called non-conduction time. Sometimes it is asking calculate off time, non-conduction time, calculate pulse width. Pulse width means not the total time period students. Pulse width means you have to calculate the pulse width is nothing but you have to calculate the on time only. That point you have to mainly concentrate. Okay. Off time means non-conduction time you have to calculate. Then average output voltage equal to V0 equal to D into Vs. This is very important formula. This also you can write V0 equal dVs. What is the duty cycle? T on by T now. This T I am writing is 1 by T I am writing as F. That is V0 equal to T on into F into Vs square. Where F is the switching frequency, T on is the on time, Vs is the supply voltage. Once you know the average output voltage, then how to calculate the average output current? The average output current I0 equal to V0 by R. Then it is a R load or RL load, you can apply V0 by R. If it's RE load or RLE load, we can apply I0 equal to V0 minus E by R. Like this, we have to calculate the average load current in the case of step down chopper or buck. All these formulas are buck regulators. Then one more important formula, what is the average inductor current? The average inductor current equal to I0. In a buck regulator, what is the average inductor current? I0. What are the RMS value of inductor currents? Very, very important formulas that you have to concentrate. The RMS inductor current equal to IL average square plus delta IL by 2 root 3 whole square whole to the power of 1 by 2. This is the average inductor current. This is the RMS inductor current. Every formula is important. Then what is the average value of diode current? That is a freewheeling diode current. The average value of freewheeling diode current equal to IL average into 1 minus T. But what is IL average here? IL average equal to average load current. IL average is nothing but average inductor current. Average inductor current. That you have to concentrate. Next, what is the RMS value of freewheeling diode current? RMS freewheeling diode current equal to RMS value of freewheeling RMS value of inductor current into square root 1 minus D. That you have to concentrate. Next, in a buck regulator or step down chopper, what is the peak voltage across the switch? Peak voltage across the switch equal to Vs square. Peak voltage across the switch. Next, one more important formula. What is the average source current? The average source current equal to di0. Very, very important form. Final formulas you have to concentrate. To calculate the average source current, let assume that lossless chopper. In lossless chopper, input power equal to output power strength. This is the observation. In a lossless chopper, input power equal to output power. If it is asked what is the percentage efficiency of the chopper, input power by output, sorry, is a percentage efficiency. Percentage efficiency, how we can define, students? That is a output power by input power into 100. Sometimes if it is asked what is the efficiency of the chopper, you have to remember this formula. Next, this is the observation for buck regulator. Step down chopper is a DC equivalent of step down transformer. Why? Because in a step down chopper, voltage is step down but current is step up. Voltage is step down, students. Voltage is step down. That is voltage going to reducing, current is increasing. Like in step down transformer also same. In step down transformer, what happened? What happening in step down transformer? Output voltage is reducing. That is secondary voltage is reducing. Secondary current is increasing. Like this, in step down chopper also, output voltage is reducing, output current is increasing. That's why it is a DC equivalent of step down transformer. Next, what are the peak to peak inductor ripple current, students? This very, very important 5-star gunshot formula. A peak to peak inductor ripple current, 5-star formula, students. Many times the questions are already framed in GATE exam. In the case of buck regulator, the peak to peak inductor ripple current equal to D into 1 minus D into Vs by Fl. D into 1 minus D into Vs by Fl, students. Then in a buck regulator where the ripples are maximum. In buck regulator, ripples are maximum at duty cycle equal to 0.5. In buck regulator, the ripples are maximum at duty cycle equal to 0.5, students. Then what is the maximum value of ripple current? The maximum value of ripple current equal to Vs by 4Fl. That you have to concentrate. Maximum ripple current equal to Vs by 4Fl. Where the ripples are maximum? D equal 0.5. What is the maximum ripple current? Vs by 4Fl. Next, what is the maximum inductor current? The maximum inductor current equal to IL average plus delta IL by 2. Delta IL is the peak to peak inductor ripple current. What is IL average, friends? In a buck regulator, IL average is equal to I0. That I already given. Then what is the minimum inductor current? Every formula is important. Minimum inductor current equal to IL average minus delta IL by 2, students. Once you know the maximum inductor current and minimum inductor current, once you know the maximum inductor current and minimum inductor current, students, once you know the maximum inductor current and minimum inductor current, then how to calculate the average inductor current? The average inductor current equal to IL maxima plus IL minima by 2. That is equal to I0. That you have to concentrate. Next, what is the peak current through the switch? Very, very important 5-star gunshot formula. In a buck regulator or step down chopper, the peak current through the switch equal to maximum inductor current. Peak current through the switch is nothing but a maximum inductor current. That is IL average plus delta IL by 2. IL average plus delta IL by 2. Next, what are the critical inductance, students? Critical inductance is calculated at just to continuous at boundary condition. Critical inductance is calculated just to continuous or boundary condition. Then what is the value of critical inductance, students? Final formula only have to concentrate. No need to concentrate on the derivation because this is the only for quick revision point of view that I am giving. You also prepare only formulas. This is a final preparation now. Then critical inductance LCR equal to R into 1 minus D by 2F. R into 1 minus D by 2F. where R equal to load resistance. Sometimes the question is asking by giving the critical inductance what the resistance it is asking. That type of question already framed in GATE exam for 2 marks. That also you have to concentrate. Next, the value of duty cycle at just continuous. What is the value of duty cycle at just continuous? This also 5-star formula. T equal to 1 minus 2L by RT. If given inductance or circuit inductance greater than the critical inductance, then it is a continuous mode, friends. If the given inductance equal to critical inductance, then it is a just continuous. If given inductance or circuit inductance is less than the critical inductance, then it is a discontinuous mode of operation. At these points you have to concentrate. But the RMS output voltage, of buck regulator equal to root D into Vs, where D is the duty cycle strength. Then this is the 13th. Form factor equal to V naught RMS by V naught na, root D Vs by D Vs na, that is 1 by root D. Form factor equal to 1 by root D strength. That you have to concentrate. Then what the ripple factor? Ripple factor equal to square root form factor square minus 1 strength. Ripple factor equal to square root form factor square minus 1. And then this is the formula for ripple factor. Every formula is important. What is the effective value of input resistance? The effective value of input resistance in the case of buck regulator or step down chopper is R effective value equal to R by D. R effective value equal to R by D. With that you have to concentrate. Next. These are the waveforms. No need to concentrate on the waveforms. Leave it. This is the inductor current waveform. This is the capacitor current waveform. This is the voltage across the capacitor waveform, friends. Just see this waveform. No need to practice this one. This is the voltage across the capacitor waveform, and this is the capacitor current waveform, friends. Capacitor current waveform, and this is the inductor current waveform. Mainly from this, very important is what the peak to peak capacitor ripple voltage, 5-star gunshot formula. Nowadays the trend is going, the formulas based on the questions are asking based on the formulas of capacitor related formulas, because already so many times inductor related formulas already over. Recently from last 2 to 3 years the questions are asking from the capacitor related formulas, students. That's the reason why concentrate on the capacitor related formulas also. The peak to peak capacitor ripple voltage equal to D into 1 minus T into Vs by 8 LCF square. Where the ripples are maximum. Ripples are, even capacitor ripples also maximum at duty cycle equal to 0.5. What the maximum value of capacitor ripple voltage, friends? The maximum value of capacitor ripple voltage equal to Vs by 32 LCF square. 32 into L into C into F square, friends. L into C into F square. That is the maximum capacitor ripple voltage. Next. What is the maximum voltage across the capacitor? Maximum voltage across the capacitor is nothing but a maximum voltage across the load. Why? Because in a buck regulator, in any regulator, the capacitor and load is parallel. Capacitor is connected across the load only, na? Capacitor is connected across the load only. That's the reason why voltage across the capacitor is nothing but a voltage across the load. This is the peak voltage across the capacitor. That is maximum voltage across the load. This is the minimum voltage across the capacitor. That is the minimum voltage across the load. If it is asked what the maximum voltage across the load, apply this formula. V0 plus delta Vc by 2. If it is asked what the minimum voltage across the capacitor, apply V0 minus delta Vc by 2. This is a capacitor related formulas. And what are the critical capacitance? Very important formula. The critical capacitance CCR equal to 1 minus D by 16 LF square. In the case of buck regulator or step down chopper, what are the critical capacitance? CCR equal to 1 minus D by 16 LF square. Next, what is the average voltage across the load? This is the average voltage across the load by considering the internal resistance of the inductor. That is called practical case. Still now the question is not framed, but we can expect, friends. This is the expected model of formula. From this formula we can expect the question. That is, if internal resistance of the inductor is given, let small r is the internal resistance of the inductor. Then when it is a practical case, when it is ideal case. If internal resistance of inductor is given, that you have to take the practical case. If internal resistance of inductor is not given, that is you take the ideal case, friends. By considering the internal resistance of the inductor, what is the average output voltage? By considering the internal resistance of the inductor, average output voltage equal to dVs by 1 plus small r by capital R. Small r by capital R. What is the small r here? Internal resistance of inductor. Internal resistance of inductor. Internal resistance of inductor. What is the capital R? Capital R is the load resistance. Capital R is the load resistance. This is the practical case average output voltage. This is the ideal case average output voltage. Then in a practical case, the output voltage by input voltage, that is called gain. Gain is D by 1 plus small r by capital R. Sometimes it is asking the gain also. Next, what are the discontinuous mode analysis? In discontinuous mode of buck regulator, then what formulas we have to mainly remember? This average output voltage, dVs by beta. dVs by beta, student. Always average output voltage in discontinuous mode greater than as compared to average output voltage in continuous mode. And one more formula you have to remember in discontinuous mode, the average switch current. The average switch current equal to 1 by 2 into IL maxima into D, students. 1 by 2 into IL maxima into D. For the average diode current, the average diode current equal to 1 by 2 into beta minus D into IL maxima. What is beta? Beta is nothing but a fraction of time at which current is 0. Discontinuous mode means before completing one time period current is 0 na. Before completing one time period, at what fraction of time current is 0, that is the beta. If beta is given, then that is nothing but a discontinuous mode of operation. Okay, this is the average diode current. Then in a discontinuous mode, peak to peak inductor ripple current is nothing but a maximum inductor current. Why, sir? In a discontinuous mode of operation, minimum inductor current equal to 0. In discontinuous mode, students. In discontinuous mode of operation, IL minima equal to 0 na. If IL minima is 0, generally what is delta IL? Delta IL equal to IL maxima minus IL minima. IL maxima minus IL minima. But in discontinuous mode, what is IL minima? 0. That's why the peak to peak inductor ripple current is nothing but a maximum inductor current. Peak to peak inductor ripple current is nothing but a maximum inductor current. And this question you have to practice. What are the formula that I given? You have to find average. Just by seeing this circuit, what is the chopper? This inductor is at load side na. Across the load there is a diode na. That's the reason why it is a which chopper? Step down chopper or buck regulator. Find the average voltage, average current, peak to peak inductor current, critical inductance, peak to peak capacitor ripple voltage, critical capacitance, average source current, that is average diode current. Every formula you have to know. You please practice this question, friends. Please practice this one. Critical inductance, peak to peak capacitor ripple voltage, critical capacitor. Just practice this model. Yeah, this is enough. Then what is the average? So that is the average force current na di naught. Average diode current means that is the freewheeling diode current. IL average into 1 minus D. Average peak value of switch current. Peak value of switch current equal to IL average plus delta IL by 2. That is about the buck regulator. Then one more circuit is operation and analysis of boost regulators. Operation and analysis of boost regulator. That is analysis of boost regulator is nothing but a step up chopper. Boost regulator is also called step up chopper. Just by seeing the circuit, how to identify it is a boost regulator? Yes. Inductor is at which side, friends? Inductor is at the source side. If the inductor is at source side, then it is a boost regulator. And one more observation you have to concentrate. If switch is grounded, that is a boost regulator. Switch is grounded, na boost regulator. If inductor is grounded, that is a buck regulator. If L is grounded, that is buck boost regulator, not buck regulator, buck boost regulator. Switch is grounded, boost regulator. Inductor is grounded, buck boost regulator. Remaining is buck regulator. That is neither switch grounded nor inductor is grounded. Neither switch is grounded nor inductor is grounded. Then that is nothing but a buck regulator. That is remaining is the buck regulator, students. Where L is the filter inductor, C is the filter capacitor. What is L and C here, sir? It's not load related. These are the filter related. L is the filter inductor, C is the filter capacitor. This switch arrangements, na, the switch may be any device. Here switch may be any device. That point you remember. In framing of the questions, instead of switch arrangement, they will give the MOSFET, they will give the BJT or IGBT, GTO or SCR. Any device they will give. Again, don't think SAR is not explain about MOSFET, BJT like this. Instead of switch, here I given the general representation. They will replace the switch maybe MOSFET, just like this question. Actually, here I given the switch arrangement. Now, instead of switch arrangement, what they given? MOSFET. MOSFET arrangement they given. That is the meaning. Any switch, any device is used as a switch. Then, what is the operation? During chopper is on state, what is the voltage across the inductor? In the case of boost regulator, this is a boost regulator, na? That is a step up chopper. That is VL equal to VS. What is the current through the capacitor? IC equal to minus I naught. Next, during chopper is off state, What the voltage across the inductor? Why I'm telling these formulas? Based on these formulas also questions are framing. That's why I'm giving these formulas. What the current through the capacitor? What the current through the capacitor? IL minus I naught. That you have to concentrate. Next, what the average output voltage, friends? In the case of boost regulator or step up chopper, average output voltage equal to Vs by 1 minus D. Then in the chopper, V naught greater than Vs. Why the name is given as a step up chopper? In the chopper, V naught greater than Vs. In step down chopper, V naught less than Vs, friends. In step down chopper, V naught less than Vs. But in the case of step up chopper or boost regulator, V naught greater than Vs. That is average voltage is average output voltage greater than as compared to supply voltage. That is in step up chopper, in step down chopper, what about V naught? V naught less than Vs. In step up chopper, in step up chopper, what about V naught? V naught greater than Vs. That you have to concentrate. Then this is the average load current. If it is a R load, RL load without any battery, then you have to use the formula I naught equal to V naught by R. If the load consists of battery, students, you have to use the I naught equal to V naught minus E by R. I naught equal to V naught minus E by R. And these are the waveforms, no need to practice. This is the inductor current waveform. This is the diode current waveform. Actually, this diode current waveform is practically, the shape is just like a trapezoidal waveform, students. That you have to concentrate. What is the average inductor current? The average inductor current equal to I naught by 1 minus D. But in the case of buck regulator, what the average inductor current is equal to I naught. But here I naught by 1 minus D. Then what is the average inductor current? I naught by 1 minus D. What is the RMS inductor current? Similar to buck regulator. IL average square plus delta IL by 2 root 3 whole square whole to the power of 1 by 2. Still now based on the RMS inductor current, no question is framed, but in future we may expect. For your exam point of view also it is important. Next, what is the average diode current? Average diode current equal to IL average into 1 minus D. What is the RMS diode current, friends? IL RMS into square root 1 minus D. Very, very important formulas. 5-star formulas. Next, what is the peak voltage across the switch? Peak voltage across the switch equal to Vs plus VL, that equal to V naught. What is the average source current? Average source current equal to I naught by 1 minus D. In buck regulator, average source current equal to D I naught. But here I naught by 1 minus D. Here observation is, in the case of boost regulator, voltage is increasing, current is reducing. That's why it is a DC equivalent of step-up transformer. In step-up transformer also what happened? In step-up transformer, voltage, secondary voltage increases, secondary current is reduces. Here output voltage increases, current is reducing now. That's why it is a DC equivalent step-up transformer. Then what is the peak-to-peak inductor ripple current? Simple formula, very important, dVs by FL. In the case of boost regulator, what the peak-to-peak inductor ripple current? dVs by FL. But in the case of buck regulator, D into 1 minus D into Vs by FL. Where the ripples are maximum at D equal to 0.5. But in boost regulator, ripples are maximum at D equal to 1. Still now not framed, but we can expect. In boost regulator, where the ripples are maximum at D equal to 1. In buck regulator, where the ripples are maximum at D equal to 0.5. But what is the maximum inductor ripple current? Vs by 4Fl. But in the case of buck regulator, what is the maximum inductor ripple current, friends? Vs by 4Fl. But here Vs by Fl only. Next. What is the maximum inductor current formula? Same. IL average plus delta IL by 2. But here IL average is different. In IL average in buck regulator is I naught. But here I naught by 1 minus D. Na? I naught by 1 minus D. What is the minimum inductor current? The generalized formulas are same, but this formula is changing as compared to buck regulator. Then IL average minus delta IL by 2. IL average equal to maximum current plus minimum current by 2. Na? This is equal to I naught by 1 minus D. Every relation is important. Then what is the peak current through the switch? Peak current through the switch equal to IL average plus delta IL by 2. What is the average source current, friends? Average source current equal to average inductor current equal to I naught by 1 minus D. Average source current equal to average inductor current equal to I naught by 1 minus D. Average switch current equal to average value of switch current. This is the average switch current, friends. D into IL average. What the RMS switch current? Root D into IL average. RMS switch current equal to root D into IL average. This is RMS switch current that you have to use. This is the average switch current. This is the RMS switch current. This is root. This is IL RMS. Na? That's why you have to use. This is not IL average. You have to use IL RMS. You have to use the. This is what you have to use IL RMS. How to use? Because in RMS calculation you have to use the RMS. In average calculation you have to use average value. In RMS calculation you have to use RMS value. IL RMS formula already given. For the critical inductance formula, in the case of boost regulator or step up chopper, the critical inductance LCR equal to R into D into 1 minus D whole square by 2F. Very, very important 5-star formula. R into D into 1 minus D whole square by 2F. 2F students. Then if L given equal to L circuit, then it is nothing but a continuous. That is the L given greater than L critical. L circuit is greater than L critical. Then it is a continuous mode. If L circuit is less than LCR, then it is a discontinuous mode. If L circuit is equal to L given, that is L circuit, nothing but L given equal to L critical, then it is a just continuous. Already given that conditions in buck regulator also. Next, to calculate the capacitor related formulas, these waveforms are important. This is the inductor current waveform. This is the capacitor current waveform. This is the capacitor voltage waveform, friends. Voltage across the capacitor is nothing but a load voltage. Voltage across the capacitor is nothing but a load voltage. Then what is the peak to peak capacitor ripple voltage? This formula is important here. They don't ask any waveforms. The peak to peak ripple voltage, capacitor ripple voltage equal to di naught by Fc. What the maximum ripples are maximum at duty cycle equal to 1, because in boost regulator ripples are maximum at D equal to 1, friends. What is the maximum value of capacitor ripple voltage? Maximum value of capacitor ripple voltage equal to I naught by Fc. Then what is the critical capacitance? Before that, this is the maximum voltage across the capacitor. Maximum voltage across the capacitor is nothing but a maximum average voltage. Minimum voltage across the capacitor is nothing but a minimum average output voltage, friend. Then this is the critical capacitance formula. What is the critical capacitance? Very, very important 5-star formula. What is the critical capacitance? CCR equal to D by 2FR. In the case of boost regulator, critical capacitance equal D by 2FR, where R is the load resistance, friends. Then practically, what is the average voltage across the load? Practically means they given the internal resistance of the inductor. Then the practical voltage in the case of boost regulator is 1 minus D into Vs by small r by capital R plus 1 minus D whole square. Then this is the average output voltage in practical case. Practically the average output voltage equal to 1 minus D into Vs by small r by capital R plus 1 minus D whole square. And this is the conditions where this average output voltage is maximum. At what value of average output voltage is maximum? But if you compare this is the practical case formula, students. Then if you compare the practical case and ideal case, ideally the output voltage is continuously increasing. But practically the output voltage is after reaching the maximum value, the output voltage is reducing. This is the practical case and this is the ideal case. But ideally for D equal to 1, voltage is infinity. But practically for D equal to 1, voltage 0. This is important. Most of the time the question is repeated in all the competitive exams. In a boost regulator, even in buck boost regulator also, very important. In boost regulator or buck boost regulator, practically the average output voltage for D equal to 1, not infinity. If you substitute directly in this formula, you can get infinity. That is wrong. Practically, this is not the formula. Practically, this is the formula. Substitute D equal to 1 here. We can get average voltage is 0. Practically, what is the average voltage for D equal to 1 in a boost regulator and buck boost regulator? That is not infinity. It is a 0. Point you have to remember. Then at what value of duty cycle? Practically the output voltage is maximum. The output voltage is maximum at a duty cycle of D equal to 1 minus square root small r by capital R. Small r is the internal resistance of inductor, capital R is the load resistance. Still now based on these formulas the questions are not framed, but you can expect, friends. Duty cycle at maximum output voltage practically. What is the maximum average output voltage practically? The maximum average output voltage practically Vs by 2 into square root capital R by small r. The only difference between ideal case and practical case, if small r is 0, that is internal resistance of inductor is not given, That is the ideal case. If the internal resistance of inductor is given, that is a practical case, friends. Next, this is the proof. Why in boost regulator practically for D equal to 1 average output voltage is 0. For D equal to 1, then source is disconnected. Then who supplies the current to the load? Then capacitor is shunted across the load. Once the capacitor is shunted across the load, the average output voltage is 0. Then one more circuit, one more observation that you have to concentrate. Discontinuous mode analysis of boost regulators. Discontinuous mode analysis of boost regulator. In discontinuous mode of analysis, we can get the beta. Mainly which formulas you have to remember? No need to concentrate on the waveforms. This average output voltage formula you have to remember. V naught equal to beta into Vs by beta minus D. Beta into Vs by beta minus D. Beta. If beta equal to 1, it becomes a continuous mode. This is the discontinuous mode. Beta into Vs by beta minus D. We also remember what is the average switch current, what is the average diode current. In discontinuous mode, I told already IL minima equal to 0. Then peak to peak inductor ripple current equal to maximum inductor ripple. Peak to peak inductor ripple current equal to maximum inductor ripple current. This is with respect to discontinuous mode of operation. Up to now, buck regulator is completed, boost regulator is completed. Then one more important circuit with respect to DC to DC converter, that is the buck boost regulator. DC to DC converter, that is the buck boost regulator. Just by seeing the circuit, how to identify the buck boost regulator, friends? The inductor is at middle like this. That is inductor is grounded. Then it is nothing but a buck boost regulator. The switch may be any device. It may be MOSFET, IGBT, BJT, GT or SCR. Based on the frequency of application and based on the power application, we can use this one. But MOSFET is more preferable for high frequency, friends. MOSFET more preferable for, very important, more preferable for high frequency and SMPS. For high frequency and SMPS applications. High frequency and SMPS application. MOSFET is more preferable for high frequency and SMPS application. Then, what is the operation and analysis of buck boost regulator? If the chopper is on state, that is the voltage across the inductor. This is the capacitor current. If the chopper is off state, this is the voltage across the inductor. This is the current through the capacitor. Direct formulas it is asking. That's why I'm telling that this statement. Then what is the average output voltage in the case of buck boost regulator? The average output voltage, that is up down chopper. V naught equal to dVs by 1 minus D. Why the name is given as a buck boost regulator? For 0 to 0.5, V naught less than Vs, it acts as a buck regulator. If you substitute 0 to 0.5 duty cycle here, we can get the V naught less than Vs. That's why it is a buck regulator. If you substitute 0.5 to 1, friends, we can get V naught greater than Vs. That's why it acts as a boost regulator. That is up to duty cycle 0.5. That is for duty cycle less than 0.5, it acts as a buck regulator. Duty cycle greater than 0.5, it acts as a boost regulator. Duty cycle less than 0.5, buck regulator, sir. Duty cycle greater than 0.5, boost regulator. If the duty cycle is equal to 0.5, neither buck regulator nor boost regulator. That is V naught equal to Vs. It cannot step up, it cannot step down. Then this is the average output current. This is the, for R load or RL load, V naught by R. If there is a battery, you have to write the V naught minus E by R. These are the waveforms of inductor current and switch current and diode current, friends. Then what is the average inductor current? The average inductor current equal to IL equal to I naught by 1 minus T. Actually, in the derivation, we can get negative sign. But this negative sign is I naught is opposite to IL. That's the reason why we are getting negative sign. But no need to consider the negative signs, friends. IL average equal to I naught by 1 minus T. Same formulas. Most of the formulas in buck boost regulator is similar to boost regulator formulas. Some formulas only will change. V naught formula and one more is critical inductance formula. Some formulas only. One or two or three formulas only different. Remaining formulas are similar to boost regulator only. Once you remember the boost regulator formulas, easy to remember for buck boost regulators. This is the RMS inductor current waveform. This is the average inductor current waveform. Then what is the average value of diode current? Same. IL average into 1 minus T. What is the RMS value of diode current, friends? IL RMS into square root 1 minus T. Square root 1 minus T. What is the peak voltage across the switch? Important formula. VL plus Vs. What is the average source current? Average source current equal to di naught by 1 minus T. Di naught by 1 minus T. In the case of buck boost, this is different as compared to boost regulator. Average source current equal to di naught by 1 minus T. Next, What is the peak to peak? This is similar to boost regulator only. dVs by FL. Peak to peak inductor ripple current equal to dVs by FL. Where the ripples are maximum. Ripples are maximum at d equal to 1. Similar to which one? Boost regulator. What is the maximum inductor ripple current? Maximum inductor ripple current equal to Vs by Fl. Similar to boost regulator. Most of the formulas are similar to boost regulator. This is the maximum inductor current. This is the minimum inductor current. Minimum inductor current. Once you know maximum inductor current and minimum inductor current, you have to calculate the average inductor current. The average inductor current equal to, that is the maximum inductor current plus minimum inductor current by 2. Maximum inductor current plus minimum inductor current by 2. This is the average inductor. Once you know the maximum current and minimum current, you have to calculate peak to peak inductor ripple current. That is IL maxima minus IL minima. Maximum value minus minimum value is called peak to peak inductor ripple current. Next, what the critical inductance? This is the formula for critical inductance. R into 1 minus. This formula is different as compared to boost regulator. In boost regulator, D into 1 minus D whole square you can get, but here only 1 minus D whole square. Okay. Then if L greater than LCR, continuous mode, L less than LCR, discontinuous mode, L equal to LCR, just continuous. Not only with respect to inductance, with respect to duty cycle also you can compare. PL by RT greater than 1 minus D whole square, continuous mode. PL by RT less than 1 minus D whole square, discontinuous mode. PL by RT equal to 1 minus D whole square, that is the just continuous mode. Then to derive the peak to peak capacitor ripple voltage and critical capacitance, we have to draw the capacitor current waveform and voltage across the capacitor waveforms. Then what is the peak to peak capacitor ripple voltage? Similar to boost regulator formula, that is di naught by Fc. We know that ripples are maximum at d equal to 1, similar to boost regulator. Then what the peak to peak maximum value of capacitor ripple voltage? The maximum value of capacitor ripple voltage is equal to I naught by Fc. That you have to concentrate. Next, what is the maximum voltage across the capacitor? Maximum voltage across the capacitor is nothing but a maximum average voltage. Minimum voltage across the capacitor is nothing but a minimum average output voltage. Then what is the critical capacitance? This is also similar to boost regulator formula. D by 2Fr. Critical capacitance equal to D by 2Fr. Then what is the peak current through the switch? Peak current through the switch is nothing but a maximum inductor current. That is IL average plus delta IL by 2. Peak current through the switch equal to IL average plus delta IL by 2. Next, what is the average voltage across the load? This is the practical case. Practically, this is the average voltage. Still now not framed in competitive exam, but this is the expected model. That's why don't leave this concept. It's very important, sir. Up to the trend is given up to discontinuous mode. Next, they are enter into the practical case also. That's the reason why you have to remember V naught equal to D into 1 minus D into Vs by small r by capital R plus 1 minus D whole square. This is the expected model of problem from this formula, friends. And this is the characteristics for practical case. This is the characteristics for ideal case, and this is the unstable characteristics. From this point to this point, unstable, friends. From this point to this point, only stable characteristics. Even boost regulator also, that you'll see from this point to this point up to D maxima, duty cycle D maxima, that is the stable operation. Greater than D maxima, it is unstable operation. D maxima in the sense that is the duty cycle, not a maximum duty cycle. D maxima is not a maximum duty cycle, sir. This is the duty cycle at maximum output voltage. Duty cycle at a maximum output voltage. What the duty cycle at maximum output voltage? This is the formula. In the case of which regulator? Buck boost regulator. What the maximum average output voltage practically? This is the maximum average output voltage practically. This is the duty cycle at which one? Maximum average output voltage. These points mainly have to consider. And what the discontinuous mode analysis? In discontinuous mode, V naught discontinuous mode equal to dVs by beta minus D. Always discontinuous mode average voltage greater than as compared to continuous mode average voltage. And these are the formulas in discontinuous mode. Discontinuous mode means before completing one time period, current is 0. Before completing one time period, current is 0. This is the average switch current, similar to boost regulator. Average diode current you have to remember. In discontinuous mode, always maximum inductor current is nothing but a peak to peak inductor ripple current, because IL minima equal to 0. What about in discontinuous mode, friends? IL minima equal to 0. And these problems you have to practice, friends. Every problem you have to practice. This is the final preparation. Once you practice the formulas, you have to practice this problem. This is problem based on the which one? buck regulator that you have to consider. This is according to T on by T of T on equal dt, T of equal to 1 minus d into T that you have to consider. And this is the problem based on which regulator? Buck regulator. Buck regulator, how to identify? Because inductor is at load side. This is also based on the buck regulator form. You have to find the peak to peak inductor ripple current. Then in this problem, try to solve all these questions. Average inductor current, average source current, every formula you know na. This is the expected models of questions for every regulator. This is the expected model of questions for every regulator or every chopper. Then this is a question based on which one? Boost regulator, because inductor is at source side na, it is a boost regulator. You have to find the peak to peak inductor ripple current na. What the formula? dVs by Fl. Direct formula based questions. In the above problem, we calculate all these. V naught, I naught, average inductor current, average source current, peak current through the switch, average switch current, RMS switch current, average diode current, RMS diode current, peak to peak capacitor ripple voltage, critical capacitance, critical inductance. All this you have to calculate, student. This once we can cover all these questions, any question we can expect in gate exam. That's the reason why you try to practice these ones. And this is the question based on which one? Buck boost regulator. Why inductor is at middle? Buck boost regulator that you try to solve. And average inductor current I solve. In the above problem, you try to practice this one. Average inductor current, average source current, peak to peak capacitor ripple voltage, critical capacitance, critical inductance, average diode current, RMS diode current, average switch current, RMS switch current. Then this is the question based on which one? This is also question based on the buck regulator, because inductor is at load side. This is the repeated that you have to concentrate. Not repeated, no. You have to calculate the what it is asked on off ratio. Then it is asking that what is the that is average current. It is asking that 10 ampere. Try to practice. This is also repeated question that you have to concentrate. And this is the peak to peak inductor ripple current. This is the question again repeated that you have to check it. This question is also repeated. Then this is the question on based on which one? Buck regulator. This is the question based on the buck regulator. And this question is also based on which one? Step down choker. This question is step down choker. Here it is asking that duty cycle that you have to concentrate. Yeah, this model is also very important. Please concentrate this model. Then this is the question based on buck regulator with respect to practical case. This question I framed with respect to practical case, that buck regulator practical case. And this model is repeated model in gate exam. Peak current through the switch. What is the peak current through the switch? IL average plus delta IL by 2 squares. And this is also question based on the critical inductance. This is the previous gate question only. This is the critical inductance. Which regulator? Buck regulator. That is step down choker. For D equal to 1 average output voltage. This is the practical case. For D equal to 1, what is the average output voltage? 0. Then this is the simple question. This is the question based on the boost regulator. This is a question based on the boost regulator. Next, this is the question based on which one? Inductor is at source side na. That's why it is a boost regulator question. Here it is asking that what is the average source current? Average source current equal to I got 5 by 3 amperes. And this is also question based on which one? Yes, boost regulator. It is asking that critical inductance. Try to solve this one. Critical, I am leaving for you. Practice this one. Critical inductance. R into D into 1 minus D whole square by 2F. Please check it. Maybe you can get 12.5 something. You please do that one. Next, you have to, this model is also important. Sometimes it is asking that calculate the switching frequency, calculate the on time, calculate the off time. That type of models also it is framing students. This model is also important. You have to consider. And this is the question on the buck boost regulator. You have to find the peak to peak inductor ripple current, dVs by Fl formula you have to use and try to solve this one. Maybe you can get 0.8 ampere something. You please do that one. Next, this is the also buck boost regulator, because inductor is at middle na buck boost regulator. You have to find the peak to peak capacitor ripple voltage. Peak to peak capacitor ripple voltage. Important models. Peak to peak capacitor ripple voltage. Practice this. And this model is repeated in gate exam. Just we have to apply the volt second balance, then we can solve this one. VL on into T on plus VL off into T off. This is on time voltage, this is off time voltage. T on is nothing but a DT. T on is nothing but a DT students. T off is nothing but a, just no need to remember any formula here. No need to remember any formula. VL on into T on. VL off into T off. Use that one, then try to solve that one. This is the question based on the practical case of the boost converter. Try to solve this one. practical case of the boost converter. In practical case of the boost converter, the average output voltage formula you know na, 1 minus D into Vs by small r by capital R plus 1 minus D whole square. This is the practical case, friends. Then this is the question based on the buck regulator, and here directly duty cycle not given, they given the waveform. From this waveform you calculate the duty cycle, then apply the formula, then you can solve. Sometimes they don't give duty cycle directly, from the waveform only you have to calculate. This is the question, this is also repeated question that you have to consider, that you got 0.8 amperes. Actually I given the practice, I solved here 0.8 ampere, and here I got 0.24 volts, already given this one, but this I am solved. Solution also I given, friends. You are not getting solution na, here I solve that models of questions. Please practice this one. Next, one more topic with respect to choppers. Up to now I completed buck regulator, boost regulator, buck boost regulator. That three circuits, 99% we can expect the questions only from these three circuits. If they are not asking the questions from that three circuit, they directly enter into the types of choppers based on the commutation. But before going to that one, you have to see types of choppers based on the quadrant operations. We know that type A chopper is the first quadrant chopper, type B chopper is the second quadrant chopper, type C chopper. Quadrant operation also important. Type C chopper is the first and second quadrant, type D chopper is the first and fourth quadrant chopper, type E chopper is the fourth quadrant chopper. Easy to remember. A is first quadrant, B is the second quadrant, C is the first and second, D is the first and fourth, E is the fourth quadrant chopper. Four quadrant means four quadrants. That is 1, 2, 3, 4. In four quadrants it will operate. Then type A chopper, friends. Type A chopper circuit you have to remember. How to identify the type A chopper? A diode across the load. It is a which chopper? First quadrant chopper. It is used only for which application? Forward motoring control. What about V0 greater than? This is very important. Type A chopper, V0 greater than 0. This is also asking. V0 greater than 0, I0 greater than 0. First quadrant, forward motoring. Power is delivered from. What is the power? Power is positive. Power positive means power is delivered from source to load. That you have to remember. Next, type B chopper. How to identify the type B choppers, friends? Diode is at source side. Here diode across the load. Here diode at source side. Then it is a which chopper? Type B chopper. Type B chopper, what about V0? Greater than 0. What about I0? Less than 0. It is a which quadrant? Second quadrant chopper. Which operation? Forward braking. What is the power? Power is negative. Power is negative means power is delivered from load to source. Power is delivered from load to source. That points mainly you have to concentrate. What are the type C choppers, friends? It's a combination of that is type A and type B. It is a combination of type A and type B choppers, friends. That's why it is operated in the first quadrant and second quadrant. First quadrant V0 greater than 0, I0 greater than 0. Second quadrant V0 greater than 0, I0 less. That means in a type B chopper, V0 always positive, but current may be either positive or negative, sir. Current may be either positive or negative. That you have to remember. Type B chopper is used for both forward motoring and forward braking control. That you have to concentrate. Next, type D chopper, friends. Type D chopper is operated in which quadrant? First and fourth quadrant. First quadrant forward motoring, fourth quadrant reverse braking. First quadrant forward motoring, fourth quadrant reverse braking, friends. That you have to concentrate. In type D chopper, first quadrant V0 greater than 0, I0 greater than 0. Fourth quadrant V0 less than 0, I0 greater than 0. That means what is the observation here? In type D chopper, voltage either positive or negative, but current is always positive. Voltage is either positive or negative, na? But always current is positive. In type D chopper, average output voltage formula is also very important, sir. Average output voltage formula is also important. V0 equal to Vs into 2D minus 1. That you have to remember. Only type D chopper average voltage is important. And this is also very important. In type D chopper, duty cycle greater than 0.5 only forward motoring. Duty cycle less than 0.5 reverse braking, sir. Very important. Duty cycle greater than 0.5 means on time greater than off time. Then it is operating in motoring mode. On time less than off time. That is D less than 0.5. It is operating the reverse braking mode. Reverse braking mode. If D equal to 0.5, neither forward motoring nor reverse braking. It is not operating forward motoring. It is not operating reverse braking. That observation is also important that you have to concentrate. Next, type B chopper. Type B chopper is a 4-quadrant chopper. How many switches and how many diodes? 4 switches and 4 diodes. It is required a combination of 2 type C choppers or 2 type D choppers. That is, it is realized combination of 2 type C choppers, or it may be realized combination of 2 type D choppers. That is the type E chopper. First quadrant forward motoring, second quadrant forward braking, third quadrant reverse motoring, fourth quadrant reverse braking. Then it is operated in the first and third quadrant, students. It is operated in the first and third quadrant. Type E, that is which devices are operated in the first and third quadrant? Which devices are operated in the first and third quadrant, student? In first and third quadrant, CH1, CH4, CH4D2. That is first quadrant. In first quadrant, CH1, CH4, CH4D2 is operated. In third quadrant, CH3, CH2, CH4D2 is operated. This actually still now not asked in any competitive exam, but if they ask, you ready to answer. In second quadrant, CH2D4 is operated, CH2D4 and D4D1 is operating. In fourth quadrant, CH4D2, D2D3 is operating. This is which devices are operating in which quadrant in type E chopper. Okay, this is the final conclusion that you have to concentrate. Forward motoring, forward braking. This is first quadrant is which one, students? Forward motoring. Second quadrant is forward braking. Third quadrant is reverse motoring. Fourth quadrant is reverse braking. Power is P0 is positive. Power is positive means power is delivered from source to load. Power is negative means power is delivered from load to source. Here power is positive means power is delivered from source to load. Power is negative means power is delivered from load to source. Motoring mode, source to load. Braking mode, load to source. Like that you have to remember. And this is the final conclusion points with respect to quadrant operation. Single phase half wave rectifier, single phase semi converter, three phase half wave rectifier, three phase semi converter, type A chopper. First quadrant, which application? Forward motoring. All these circuits will operate in the first quadrant only. Type B chopper only second quadrant, forward braking. No other circuit is in the second quadrant, student. Type C chopper is first and second quadrant. Only type C first and second quadrant. No other circuit is first and second. Forward brake motoring and forward braking, students. Single phase full wave rectifier, single phase full wave rectifier, three phase full wave rectifier, type D chopper is operated in first and fourth quadrant. That is forward motoring and reverse braking, students. Then single phase dual converter, three phase dual converter, type E chopper is operated in four quadrant. Four quadrants means all the four quadrant is operating. We may expect the question, which circuit is operating in which quadrant, what is its application. For that purpose, you have to remember these points. Next, one more topic is steady state analysis of type A chopper. In steady state analysis of type A chopper, students, very important is with RLE load. With RLE load, you have to remember what the maximum current expression. This is important formulas. Vs by R into 1 minus e power minus Tn by Ta by 1 minus e power minus T by Ta minus e by R, where Ta or tau A equal to L by R, students. That is the maximum current expression, and this is the minimum current expression, students. This you have to concentrate. This is the minimum current expression. In type A chopper steady state analysis, it's the minimum current expression. Then what is the peak to peak load ripple current? Peak to peak load ripple current equal to I maxima minus I minima. And this is one more formula for peak to peak ripple current. Vs by R into tan H of R by 4Fl. What the approximate value of maximum ripple current equal to Vs by 4Fl. Similar to type A chopper is similar to step down chopper. Similar to buck regulator. In buck regulator also ripples are maximum to duty cycle equal to 0.5. Now. Here also ripples are maximum to duty cycle equal to 0.5. Then very important observation, students. If you draw the ripple characteristics here, for 0 to 0.5 duty cycle, if duty cycle is increasing, ripples are increasing. For 0.5 to 1, students, for 0.5 to 1, if duty cycle is increasing, what about the ripples? Ripples are decreasing. This observation is important. 0 to 0.5, if duty cycle is increases, ripples are increases. 0.5 to 1, students, if duty cycle are increasing, ripples are reduces. Ripples are reduces. Then what is the maximum ripple current? Maximum ripple current equal to Vs by 4Fl. Maximum ripple current equal to Vs by 4. Then if inductance is increases, ripple currents are reduces. If inductance is increases, ripple currents are reduces. And one more point, very important points that you have to remember. Without increasing the inductance to reduce the ripple current, this is the ripple current expression now. Without, if inductance is increases, ripples are reduces. If frequency also increases, ripples are reduces now. That's why without increasing inductance, how to reduce the ripples? By increasing the frequency, by operating the circuit at high frequency of operation. Then what is the average current through the switch? That is the average current through the switch is maximum at duty cycle E by 2 Vs. That is at what duty cycle the average current the switch is maximum. Very important formula, still now not framed, but we can expect. At what duty cycle the average current through the switch is maximum. E by 2 Vs. What is the maximum average switch current? E square by 4 VSR. Important formula, students. E square by 4 VSR. At what value of duty cycle RMS value of freewheeling diode current is maximum? RMS value of freewheeling diode current is maximum at duty cycle of D equal, very important formula, 1 by 3 into 2 plus E by Vs, friends. 1 by 3 into 2 plus E by Vs. Then what is the maximum value of RMS freewheeling diode current? The maximum value of RMS freewheeling diode current equal to 0.3849 into Vs by R into 1 minus E by Vs in whole to the power of 3 by 2, friends. The shape of the freewheeling diode current is trapezoidal. These are the points with respect to steady state analysis of type A chopper. Next, what is the Fourier analysis of type A chopper? This is also very important. Mainly in Fourier analysis of type A chopper, what is the maximum value of nth harmonic output voltage? 2 Vs by n pi into sin n pi d. What is the RMS value of nth harmonic output voltage? But RMS value of fundamental voltage is important. This is 5-star formula. The RMS value of fundamental voltage equal to root 2 Vs by pi into sin pi d. Root 2 Vs by pi into sin pi d. This is the RMS value of fundamental voltage. Next, with respect to Fourier analysis in type A chopper, to eliminate nth order harmonic, how to maintain the duty cycle? To eliminate the nth order harmonic, the duty cycle equal to 1 by n. Very important. For example, to eliminate fifth order harmonic, what is the duty cycle? 1 by 5. Next, one more important observation. Nth order harmonic current equal to 1 by n square. Nth order harmonic current equal to 1 by n square. For example, I3. I3 is proportional to 1 by 3 square. I by 9. I3 equal to I by 9. I is the fundamental current. Like that you have to. Then based on this, I solved one problem that you have to concentrate. Sometimes they given type A chopper does not consist of fifth harmonic. Does not consist of fifth harmonic means fifth harmonic is eliminated. If fifth harmonic is eliminated, what is the duty cycle? 1 by 5. Then duty cycle is 1 by 5. What is the form factor? Form factor equal to RMS by average. No? Sorry. Form factor equal to S. RMS by average voltage. No? What is the RMS voltage? Root dVs. What is the average output voltage? dVs. Because type A chopper is similar to step down chopper. Then I got this root 5. Then you substitute here this, we can get the ripple factor. Like this you have to calculate. Then type A chopper is operated in the discontinuous mode with RLE load. How to write the formula? RLE load means before one time period current is 0. Here if the current is increasing, chopper is on, students. Chopper is on, V0 equal to Vs. During on time. This is during on time. This time is taken as a TR. What is the output voltage? Output voltage equal to Vs. Vs into TR. During off time, chopper is off, who is conducting? Freewheeling diode is conducting. If the freewheeling diode is conducting, what is the output voltage? 0. Here no device is conducting, students. If the no device is conducting, what is the output voltage? If no device is conducting, output voltage equal to E. If no device is conducting, output voltage equal to battery voltage, because it is RLE load. Then you have to write that this is the average output voltage formula in the case of discontinuous mode of type A chopper, student. Then what is the voltage control techniques in chopper? The voltage control techniques in chopper is time ratio control technique and current limit control techniques. In time ratio control technique, this is the average. Friends, we know that average output voltage equal dVs. Now, what do you mean by time ratio control technique? By controlling the on time or frequency, we can control the output voltage. That is called time ratio control technique. In time ratio control technique, again there is a two techniques are there. Constant frequency control or pulse width modulation control. What do you mean by constant frequency control? Keeping frequency is constant. Keeping frequency is constant by controlling the T on if the output is controlled. By controlling T on if the output is controlled, then that is nothing but a constant frequency control or pulse width modulation control. That is, in constant frequency control, frequency is constant. By controlling T on, output is controlled. Variable frequency control or frequency modulation control. What do you mean by variable frequency control or frequency modulation control? Keeping either T on or T off is constant, but here frequency is variable. By controlling frequency, output is controlled. Then what do you mean by current limit control? By controlling the current between minima and maxima, output is controlled. Then that is nothing but a current limit control. By controlling the current between minima and maxima, output is controlled. Then it is nothing but a current limit control. And these observations also you have to remember. In continuous mode, which is continuous? In continuous mode, which is continuous, which is a discontinuous? Load current, continuous. Discontinuous mode also discontinuous. Load voltage, That means load current, load voltage, source current. In continuous mode, among all these parameters, which is continuous, which is discontinuous. In discontinuous mode, which is discontinuous, which is continuous. That you have to remember. All this about the type A chopper, type B chopper, type C chopper, type D chopper, type A chopper, and that is the quadrant operation, steady state analysis of type A chopper, and also which one, friends, that I explained Fourier analysis of type A chopper, and these observations are very important that you have to concentrate. Yes. With this, with respect to module 3, up to now I explained types of choppers based on output voltage level. That is buck regulator, boost regulator, buck boost regulator, type A, type B, type C, type D, type E chopper, and its related practice questions, Fourier analysis of type A chopper, and steady state analysis of type A chopper. All these concepts are completed with respect to module 3. In module 3, one more important concept is types of choppers based on the commutation, that you have to see in the next session. Up to now, I discussed only buck regulator, boost regulator, buck boost regulator, and types of choppers based on the quadrant operation. This is about the session. Thank you.